Now let our function be defined or be given at the points x0, x1 up to xn, which are not necessarily equally spaced. So let the function be given by f of x0, f of x1 up to f of xn at these tabular points x0 up to xn that are not necessarily equally spaced. Then the first divided difference So this is how we define the first divided difference of the arguments x0 and x1. So it's simply given by the quotient of the value of the function at x0 minus the value of the function at x1 with x0 of minus x1 or f of x1 minus f of x0 divided by x1 over x0. Other notations for the divided difference of x0 and x1 include, so we can write it as this, or we can put it in the form, or we can write it as, you write this and then sub x1. So all these are different notations for the first divided difference of the points x0, x1. Similarly, we can define the first divided difference of arguments x1 and x2 as the value of the function at x1 minus the value of the function at x2 divided by x1 minus x2. Or we can write this one as the value of the function at x2 minus the value of the function at x1 divided by x2 minus x1. Also, if we have x3 and x2, so the first divided difference of x2 and x3 is given by f x2, x3, which is given by f at x2 minus f at x3 divided by x2 minus x3. Or you can write it as the value of the function at x3 minus the value of the function at x2 divided by x2 minus x3. Now, once we have defined the first divided difference, we can also define the second divided difference for 3 arguments. So this is how we write the second divided difference of the 3 arguments x0, x1, x2 is given by the first divided difference of x0, x1 minus the first divided difference of x1, x2. We divide by x0 minus x2. Or we can write this one just using this notation. Or you can actually start with, write this one as f x0, x2 minus f x0, x1. Okay, f x1, x2, and then x2 minus x0. So this will be, remember this is 1, x1, x2, x0, x1 divided by x2 minus x0. So similarly, we can define the third divided difference. or we can use the notation. And similarly, we can define the fourth divided difference, the fifth divided difference up to the nth divided differences. Now let's demonstrate how to do a divided difference table. So the best way to do the divided difference table is to write the consecutive values of x and the function by skipping 2 lines between consecutive values where you'll be defining the quotients. So if I have this as my x values and this as my functional values, so I have x naught, and then so I'll have here f of x naught. Now skip 2 lines and write x1, f of x1, skip 2 lines and write x2, f of x2, and then skip 2 lines and write x3, f of x3. You can extend the table depending on the values of the functions we have. So I call this one, this column, the first divided differences of the function f of x. So f of x naught and f of x1 will define what we call the first divided difference of x naught, x1. F of x1, f of x2 will give us the divided difference of first divided difference of x1, x2. F of x3, f of x2 will define the first divided difference of x2, x3. Now, next, we define the second divided differences of the function f of x. Now here, we use now these values in the first divided difference to define the values in the second divided difference column. So this difference will define the second divided differences of the arguments, x naught, x1, x2. These differences will be for the arguments x1, x2, x3. And then now this is what this column that defines the third divided differences of the function. So the second divided differences of these two values will define now the third divided differences of the arguments, x naught, x1, x2, and x3. So depending on the values of the function that you have, then you can as well define other higher order divided differences. We'll demonstrate with specific numerical values in a different session on how to come up with such a divided difference table. Just before we wrap up, let's do an example on how to specify divided differences. So an example, if we have the function f of x given by 1 over x, find the first divided difference of a and b, and the second divided difference of the arguments a, b, and c. this is a good problem. So the first thing that we need to define solution is that to define the first divided differences of the arguments A and B is simply value of the function at A minus value of the function at B divided by A minus B. So this by definition. And given f of x is 1 over x, this implies f of A the same as 1 over A, and f of B is given by 1 over B. So then this difference, f of A minus f of B, will be the same as 1 over A minus 1 over B. Now, LCM AB, A into AB is B, B into AB is A. So then we'll have that the first divided difference at arguments A and B will be AB minus A over AB divided by A minus B, which can be written as B minus A divided by AB times the reciprocal of this one, which is, or simply times, or say divided by A minus B, which is B minus A over AB times 1 over, this I can write it as negative, and then B minus A, so that I can be able now to cancel out B minus A. So by writing the denominator in that form, this part and this part cancels out. So I'll have 1 over minus AB, yes, minus AB. So this will be the solution to that given part. So the value of the first divided difference of the arguments AB will be negative 1 over AB. Now, the second divided difference of the arguments A, B, and C, by definition, is the first divided difference of AB minus the first divided difference of BC over A minus C. Now, since we have found out that the first divided difference of AB is negative 1 over AB, this implies the first divided difference of BC is the same as negative 1 over BC. So this will mean that the second divided difference of the arguments ABC will be negative 1 over AB minus 1 over BC divided by A minus C, which is the same thing as writing minus 1 over AB minus is plus 1 over BC over A minus C. Now in the numerator, A 1 over B is common, so we can have negative AB plus 1 over BC can be written as 1 over B into 1 over C minus 1 over A. So which will be 1 over B into LCM is AC and then A minus C. so that this will give us the second divided difference of arguments A, B, and C will be 1 over B into A minus C over AC divided by A minus C. And simplification of this will give us 1 over B times A minus C divided by AC, then times the reciprocal of this is 1 over A minus C. And put brackets here, and these two brackets cancels out because we are defining A minus C. So this will be 1 over B times 1 over AC, which will just be 1 over A, B, C. So that is what defines the second divided difference of the arguments A, B, and C. So in the next session, we'll demonstrate how to draw a divided difference table when we have actual numerical values. Thank you.